Let me welcome you to the 14th lecture of Drilling and Blasting Technology course. In this lecture, we will discuss the special drilling methods. This is the first lecture on that. There will be another lecture on this topic. Before that, let us retrospect our previous lectures. In previous lectures, we have mostly covered the drilling technology practiced in drilling and blasting operation. We have discussed rotary drilling, we have discussed percussive drilling, we have discussed percussive rotary drilling, we have also discussed different types of drill bits, we have discussed the influence of the rock and machines on the drilling. All these are already discussed. It has been also seen that the mainly mechanized drilling is practiced using either a rotary or a percussive action, and various type of drilling patterns used in surface and underground blasting is also covered in our previous lectures. However, there are few special method of drilling. In most of these cases, in general what we do, we carry out large dia drilling. So, those are not very commonly carried out for the drilling and blasting purposes, but those large dia drillings are carried out mainly for the excavation purposes or for creating an opening in the in situ rock mass condition. So, that is basically a special types of drilling technique which is basically practiced. Apart from that, there are two other principles which is carried out. One is drilling, or you can say cracking carried out by the flame, another is the cracking carried out by the water jet. So, these are two special things. We will discuss all these things in our coming two lectures. So, our learning objective is some of the special types of drilling technologies will be covered in lecture number 14 and lecture number 15. So, let us see what are these special methods. So, apart from the standard drilling equipment, there are units and mounting systems on the market for special and very specific applications. And what are these very specific applications? These are basically very large diameter drilling. This large diameter drilling means normal cases generally we carried out drilling up to 350 millimeter dia, which we use for carrying out drilling for blasting purposes, and some cases little bit more dia, maybe around 500 dia we carry out for some access or ventilation points also. But these very large diameter drillings are most of the times greater than 1 meter dia which is practiced, and this drilling creates basically the openings. These openings are used for the human accesses. So, these are carried out for human access, and that is why these large diameter drillings are carried out in the in situ condition, so that this can be used as the access. And this large dia drilling may be vertical, and if we carry out this vertical drilling of large dia, this may be either for the shaft sinking purpose or for the raise driving purpose, or if we carry out these are for horizontal, then it may be for it may be considered as the tunnel boring machine, where tunnels are constructed, or it may be high wall miner auger, where the blocked rock mass, blocked ore, which may be coal also, are being extracted by this high wall miner. And these two are, one is flame, another is water, which we have already discussed. So, these are the some special drilling methods can be practiced in different specific conditions. So, let us see the first large dia vertical opening which is created is called shaft sinking. In general, if we are not carrying out mechanized drilling purpose, then shaft sinking is basically carried out in manual method, where first the drilling holes are made. So, these are the drill holes made using some mechanized or manual drilling machines. So, these holes are created, then we blast these holes, and we create the fragmented rock masses at this position. Then this is the grab, cactus grab, which is basically the loading machine. This cactus grab take this fragmented rock material, load this fragmented rock material onto the tub or the bucket. This is the bucket. On this bucket, then the bucket is lifted in the upward surface or subsurface where the material has to be dumped. And as this much of additional length is excavated, then the supporting of that may be carried out either by bolting, and finally the final support will be made in terms of concreting or shotcreting. So, that is in general idea about the cyclic using the cyclic operation. Shaft sinking may be carried out like this. So, when we carried out in these cases, we carry out this shaft sinking by drilling, blasting and the excavation and loading unit operations. But in the modern method, we are having mechanized drilling system where shafts are being sunk using the drilling machines, or often it may be some cutting machines which excavated in a circular manner using a drilling rig. So, let us observe this video. This is a little bit long video and available in YouTube, but I want that you must observe this video completely, and then you can easily understand how the shaft sinking may be carried out by drilling operation.
Deep shaft constructors often encounter difficult geological conditions, such as high groundwater pressure, combined with layers of hard and soft material. There is an increased requirement to avoid dewatering during construction of shafts in order to avoid the associated settlements, which can affect a wide area. The following animation shows how the Heron Connect VSM shaft sinking equipment can install shafts quickly, safely and economically in difficult ground conditions and in inner city areas with limited construction footprints. The initial section is excavated,
so
1 to 2 meters in depth,
is created,
and a support concrete ring beam is installed. It acts as a guideway and absorbs the forces from the shaft sinking process. The first segments of the shaft are assembled and lifted in place. The bottom segment ring has an integrated steel edge, which acts as a cutting knife during the shaft sinking.
Concrete or maybe
Strand jacks are installed on the support concrete. Strand wires are connected to pockets in the cutting edge. The numbers of strands corresponds to the total weight of the shaft. The shaft is now held in position by this compact strand jack system. Preparation for the machine installation starts by using a dummy frame to position the brackets for the machine arms, which are then welded to the steel plates already cast into the concrete segments.
These are the guide
machine is assembled with the correct arm length to suit the shaft diameter.
And this is the drilling rig,
lifted into
which
the
is
shaft
placed
by a
along
mobile
the
crane and mounted
guiders
onto the
provided.
brackets.
This is in actual.
The rest of the shaft sinking equipment can now be installed. The 3 winches are used to lift and lower the machine, i.e. for regular maintenance during shaft sinking, as well as to lift it out when the shaft is complete. The energy and supply lines provide the machine with all necessary power, fluids and communication. This is an example of a complete site setup. All operations are powered and controlled from the container on the
This is
surface.
control room.
Stored
placed
data,
at the
together
surface.
with the position of the cutter boom, is shown on a graphic display, giving the operator full control of the excavation and sinking process. The cutter boom can either be controlled manually by the operator or
This
set
is
in
for
automatic
alignments.
mode for cutting the set profile in the required section. The shaft is kept full of water during sinking to balance the level of the groundwater table in the surrounding geology. In addition, the
It is
water itself is
expected
used as the
that
transport medium
generally
for the
groundwater
excavated
may
ground.
fill the
Various
area
depths
because
of the
cutting
groundwater
operation
level
is
can
carried
be
out in
handled.
wet condition. If
flexibility
not, we
of
can
its
use
telescopic
water jet
orientation
for
and
that,
slewing
but in
movements
general
allows the
most of
cutter
the
boom
cases
to
that
work in
it is
shafts
below
with
ground,
inner diameters
then
from
it is
4.5
filled with the
meters
groundwater
and
itself.
outer diameter
This
up
is
to
the
18 meters in water
specifications of this
depths up to
particular
80 meters.
shaft borer. However, different specifications are available across the different manufacturers.
The cutting arm moves
So
radially
the cut
from the
material,
center to the
it
outside
is
of the
basically
shaft.
cutting the material, and cut
In soft
material is
soil, the
pumped
cutting
out
edge on the shaft is able
through
to
a
trim
slurry
the
form.
excavation as it sinks into the ground. The cutting speed and the movement of the boom can be varied to achieve the best excavation
It's
rate.
a slurry form which is pumped out.
When it's necessary to excavate under the cutting edge, such as in hard soil,
And the
machine
rig
can
is
be
being
moved to a
lowered
lower position
to the
on the
guides.
bracket to extend the
You
reach
can
of
see
the boom.
lowering in actual case also.
Where
This is
hard soil is
telescopic.
encountered, the machine cuts out to
Rig
the
is
programmed
telescopic.
limit all around the circumference before the shaft is lowered. In rock, this controlled descent allows all of the cutting edge to be cleared before lowering. This avoids trapping the cutter boom or deviations in the shaft vertically.
So after creating an opening up to a significant distance, a significant depth, the lowering of the sidewall supports has to be carried
A
out.
slurry circuit
So
transports
this
the
is the
excavated material from the
pumping
shaft
out of the
to a
slurry,
separation
which
plant on the surface.
basically
The cutter
having
drum
the
cuts and
cut
crushes the
material.
material to a granular size
The
that
cut
can be
material
handled
is
by
sent
the
to the
integrated
settling tank.
centrifugal pump. In sticky ground conditions, an additional high-pressure feed line can be used to clean the cutting drum.
and then
The separation
fresh
equipment
water may be
is selected to
recirculated.
suit the local soil conditions. As the shaft sinks lower, precast concrete segments with rubber
So
sealing
after
gaskets
achieving the
are
significant
bolted in
depth,
place on the top of
the
the shaft.
heightening of the
Excavation, shaft sinking,
sidewalls
and
is carried
construction
out
of the
either
next
by
ring
precast
can take place
or
continuously.
by the in situ concrete.
The molds
So
for
this
the
is
segments are also
precast
supplied as
placement.
part of the shaft sinking equipment package. Segment dimensions are designed to suit the shaft's purpose. The daily sinking production
Then
is in
it
a
is
large range from 1 to 5 meters, depending on the diameter, geology, and working hours.
forced toward bottom direction hydraulically.
As
So
an
it
alternative
is
to
completely
constructing the
lowered.
shaft from
The casing is
individual
completely
segment
lowered.
rings,
This is in situ
concrete
concreting.
can also be used. Formwork, designed for the shaft diameter, is used to concrete the shaft lining in lifts of about 2 meters in height. The sinking process itself is the same as for shafts constructed with segments. This can be an advantage if the shaft is to be used for launching tunneling machines. The shaft wall can then be prepared with a built-in launch eye to exactly
So this
suit
is
the
in situ
tunneling
concreting,
equipment.
actual photograph.
An automatic bentonite lubrication system reduces friction between the shaft exterior and the
To
surrounding
make
ground during
easy
shaft sinking.
that lowering action,
The total
generally
number of nozzles
bentonite is
designed to suit the
spread
soil conditions.
between the
When the shaft reaches the final depth,
casing and
the
the
VSM machine is removed and the
host rock,
concrete base block is cast.
and after achieving the desired length, drill rig is withdrawn, then the bottom is concreted, and the shaft is
Afterwards,
completely
the bentonite in the
drained
annulus
out.
around the shaft is displaced by grout injected through the bentonite nozzle.
The water in the shaft will be
Once the grout
completely
gains
pumped out,
sufficient strength,
and
the water is pumped
the
out.
shaft sinking may be completed.
The shaft construction
And finally,
has been
the
completed
grouting may be made
without affecting the groundwater
between the
or the surrounding soil.
casing and the
The shaft is
host
now
rock.
ready to be used. Up to this point in time, Heron Connect VSM
So these are
technology
the
has been
different
used to
applications
construct
of
shafts
the
for several
shaft
different
if it is
types of
bored,
applications,
and
with many
using
more
this type of
planned in the
technique,
future.
shaft sinking may be
ventilation
carried out
and
very
emergency
fast.
shafts
Only
for
the
traffic tunnels,
initial
such as
capital
those
cost
found in
requirement
metros and
is
railways.
significantly high in these cases. So these are different applications.
Or under
This is shaft sinking in most of the European countries and American countries. The best method of shaft sinking is the shaft boring, but often we use similar type of boring for creating the raises also. Before going into this detail, let me first explain you what is raise. Raise is basically an opening where if this is the surface and there are two different underground levels, raise is basically the opening which is connecting two underground levels, and this is called raise, which is either vertical or near vertical. So, basically raising is the access way between two levels in the underground, and raise boring is a very popular method, because again just like shaft sinking, raise boring takes a little bit less time if you are comparing with the manual method or conventional method where drilling, blasting or this type of unit operations are being carried out. So, raise boring is became increasingly popular over the past 20 years, and it is having advantages like personal safety, good working condition, higher productivity, smooth walls, that is the damages to the side walls are limited, retaining walls are limited. This also gives better less air friction, that is why ventilation may be better, overbreak does not exist, high advance, that is again the high productivity is achieved. So, these are basically n number of advantages you can achieve by raise boring, and that is why raise boring is becoming very popular nowadays. However, there are few disadvantages also, say higher in initial investment, cost may be little bit higher, flexibility is very limited, you cannot have different diameter, different dimensions. If it is carrying out by boarding only, then the circular, it has to be circular in shape, you cannot have another shape, then the in house accommodation of the different features in the raise may be problematic. So, these are little bit disadvantages are there, but overall the time consumption is less, and that is why raising method is becoming nowadays very popular. Raise boring method may be classified in three parts. One is standard, another is reversible, third one is blind hole raising. What is standard raise boring? This is the method widely used system, and it consists of setting up the equipment in the upper of the two levels to be interconnected or even outside the mine, so that a pilot hole can be drilled down to a previously opened level. Afterward, the reamer head is attached to the drilling string and the raise is drilled to the upward direction. So, what is the feature? Equipment is placed in the upper level. So, this is the equipment, this is the lower level. From upper level to lower level, a pilot hole has to be initially connected. Then through the pilot hole a reamer head is attached, so that the reamer head is pulled in the upward direction, so that a rimmed hole or the large dia hole can be created. So, basically first the pilot hole is created, then it is rimmed, but the main machine is placed in the upper level. So, that is the standard raise boring technique. If you look into the next system, so this is the photograph of that one, you can see this is the pilot hole which is created, machine is in the upper level, this is the lower level, and this is the rimming head, and this rimming head is pulled in the upward direction, so that it rimmed and gradually it drilled like this, and finally you can achieve a raise of this dimension. In reversible boring system, reversible raise boring system, the same operations are carried out as before, only the difference is that the equipment is placed in the lower level, inverting the pilot hole and raising execution, which are ascending and descending respectively. So, basically if we are reversing this one and place the raise boring machine in the lower level, then the method is called reversible raise boring. Blind hole raise boring, once the rig has been erected on the lower level and the drilling is done upward in full section without a pilot hole, is called blind raising. So, that means here the upper level is this, lower level is this, and you start carrying out drilling from the lower level to upper level with a drilling head like this, which drill the material and go towards upward direction. This enable the dislodgement of the material in the bottom by gravity, which later on after few sequences which may be cleared by the LHD. So, that is blind hole raising, which is a truly large dia drilling, where these are basically rimming operation from a pilot hole which is created in the raise. So, that is why this is little bit, this raising method is little bit different, blind hole raising method, than the standard raise boring and the reversible raise boring techniques. So, let us observe one such video where you can see the raise boring is carried out. This is also available, but I want that you must see it to have some idea about the raise boring technique. This is shown from the surface for the better understanding.
This type of drilling is faster, cheaper, and cleaner than the old style
So, this
drill
is
and
the pilot
blast.
hole.
It cuts an 8-meter wide hole, hundreds of meters deep through solid rock. Big enough to swallow trucks. Lots of trucks. They call the 100 a raise bore drill. Here's why. This machine drills up, raising its cutter toward the
So,
surface.
this is the rimming head. You
Its
can see
massive
this is the
cutting
rimming
tool's
head,
called
which is
a
basically
reamer,
rimming the.
driven by hydraulic cylinders that crank out 1,000,000 kilograms of thrust. The same force blasting from NASA's latest rockets. As mines expand, they need extra
So, I want to show you here that this is the first the pilot hole is created, and then this shaft is fitted through that pilot hole, and the machine, drill machine is in the upward portion, and this is the rimming head is fitted with this shaft, and it is allowed to rim in the upward direction. So, if you little bit show
shafts for workers. Let's see how it works. First, the reamer is positioned in the target zone of an existing shaft, ready to be
you can
attached
see
to
this
the
is
drill
the
pipe.
rotation of the
The machine
reamer
up
beam.
top has to
So,
punch a pilot hole through almost a kilometer of
this is
rock
basically
to hook up with
the
the reamer
technique which
below.
is carried out, that is the pilot hole excavation.
easier said than
So,
done.
I think you can understand
Here's the
how the raise boring is carried out. So, this is the second vertical excavation, large dia boring is carried out for providing an excavated opening. Next, let us look into the horizontal large dia drilling, which is basically carried out to create a tunnel, and that is why this machine is called tunnel boring machine, or in other word TBM. So, basically TBM is nothing but a drill machine which carried out drilling of very large dia and often may go up to a 10-meter dia or something like that. Opening may be created by the TBM. So, large dia drilling may be carried out by TBM, which is horizontal or nearly horizontal drilling is carried out here. And you can see that TBM is nothing but a machine which has been developed in recent years, that has revolutionized the tunneling industry, both making tunneling after economic solution for creating underground space. There are different types of TBM occurs. Most common for the very soft rock condition is earth pressure balance machine. Otherwise, different other machines are available for weak rock condition or hard rock conditions. Machines are also available for different TBMs. So, TBM is basically consisting of a shield. These are basically large metal cylinders and trailing support mechanism. At the front end of the shield, there is a cutting wheel which is fitted with the roller cutters, and behind the cutting wheel there is a chamber which allow the crushing of the fragmented rocks which are being cut by the cutting wheel. Chamber may be under pressure for the closed faced machine, where earth pressure balancing technique is followed, or it may be open to the external pressure for the open machines. Behind the chamber there is a set of hydraulic jacks which are providing the support to the finished part of the tunnel, and TBM is being advanced against this support by the hydraulic push. So, basically the back part, if this is the tunnel and in the mouth this is the cutting head, this back part is supported, this cutting head is being forced hydraulically from this support to the front direction. So, that is the drag force observed in the TBM. Behind the shield, inside the finished part of the tunnel, several support mechanisms which are part of the TBM are located. The cutting wheel is typically rotated at a very slow speed. At a very slow speed 1 to 10 rpm, depending on the size of the strata, cutting of the rock face and the condition of the rock, and it also depends on the type of PPM, TBM, etc. And if you look into the machine details, you can see this is the cutter head. These black parts, you can see these black parts, these are the rollers, cutter rollers. Then this is the bulkhead, which is basically providing a closed chamber. You can say this is the excavation chamber, bulkhead and cutting head. Between this excavation chamber is there. So, whichever material is coming here, that is crushed and finally discharged through these openings created in the bulkhead. This is the shield up to which this is under support, and the machine, this is the motive power of the machines, which is basically forcing the cutting head through these hydraulic cylinders. So, this is the screw conveyor, this which basically take out the material. Material may be of different, there may be a different system in different cases. This is the thrust cylinder, which is basically giving the thrust, and rest, these are the gripping shoes, and rest part is basically you can consider as the finished tunnel. These are the settling tank, etc., required for the transporting system of the material. So, these are the main excavation part where drilling is carried out by this cutting head. This is the large dia drilling. In fact, we can see the details of this in the next video, and that will clear your idea about this one. In fact, we will finish after observing this video, but before finishing let me show you this video. You keep a little bit patience in this observing this video. This is basically animated video, so that you can understand the complete TBM operation, how this is carried out. So, you can see this is animated, the cutting head is being shown to you. As the cutting head is rotating, the rest part of the TBM is also shown to you. So, this is the sealed part. After this sealed part, you can see the rest part is the finished tunnel.
143 buses in weight. It has a rotating cutter
So, you
head
can
at
see
the front
as the
and a
TBM
series
cutter
of
head is
trailers
rotating,
behind
the
housing
material
all the
is
mechanical
being
and electrical
dislodged.
equipment. There are two types of TBM being used by
Rock is
Crossrail:
being dislodged or
earth pressure
fragmented.
balanced TBMs and mix shield TBMs. 6 earth pressure balance machines will be used for the 18
this is a
kilometers of tunnel
twin
through
tunnel.
the clay to the west and the riverbed deposits in the east, while 2 mixed shield machines will be used to drive the tunnels through the chalk beneath the River Thames. Depending
So,
on the
as the cutter
geology
head
below and the buildings
being
above
cut, you can
ground,
see these
each
are being forced
TBM will travel
against
between
the
90 and
shield.
150 meters each week.
Then the
ending
shields
up
are
to
being
within
advanced.
a millimeter of where it needs to be. The first part of the TBM's work is the tunneling phase.
So,
The
you can
earth
see
pressure
as
balanced
it is
TBM
rotating,
has a
material is
cutting
being
wheel
cut.
which is pressed
The
against
cut
the
material
tunnel face by
is being
hydraulic
crushed in the
cylinders. Inside the
chamber.
cutting wheel,
You can
disc
see the material is
cutters and
crushed in the
scraping
chamber,
tool loosen
and
the
finally
material.
coming into a screw
If the earth
conveyor.
is unstable and to stop the tunnel face collapsing
So, in
or
this
digging
case the
too
transportation
fast,
system,
TBM
primary
uses
transportation
the
system is
soil
a
that
screw
has already
conveyor
been dug
which
out by the
discharging
cutting
the
wheel
material
to
into a
support
belt
the
conveyor.
tunnel
You can see
face.
the material is
This
being
creates
transported
a
by a
stable
screw
environment
conveyor
for
to
tunneling
the
to move
belt
forward.
conveyor.
The tunnel
And
face
this
is
belt conveyor is
continuously
basically
monitored by
placed
pressure
in the
sensors.
finished tunnel
They
part,
check the
and
turning
time to
power
time
of
that
the
will
cutting
be
wheel and the screw
extended.
conveyor, and they also
That is
keep track of the
telescopic, and that will
material
be
that's been
extended
excavated.
in time to
The
time.
material is then taken
So, you can
away
see
on
as the
conveyor
cut
belts.
material in a slurry form is being
Once the tunneling
transported
phase
through
is
the
done,
belt
the cutting
conveyor.
wheel and screw conveyor are stopped and the ring building
So,
phase
support
starts.
system,
A
in this
complete
case you can see
tunnel
this is
ring
the precast.
consists of several
These
lining
precasts are
segments made of
placed
pre-built reinforced
in the side
concrete.
walls
These
as a
are made
support
in a
system,
special factory above ground.
and
They must match
rubber
the
packets
exact
are
size
provided
required
for sealing
taken
them.
into the tunnel on flatbed rail cars. The
You can
concrete
see these are
segments
also
fed
support
in
systems
by
are
the
also being
segment
placed
feeder and
automatically.
lifted into place using a vacuum. The hydraulic cylinders are temporarily retracted
So, that will
in
be
order
placed
to provide
automatically,
enough
and it
space
will
for
be
the new
fixed by a
segment. The
bolt
segments are
or
positioned with
screw.
millimeter precision and held in place by
You see these
cylinders
packers are
before
fixing that
being
one.
finally bolted into position. The conical keystone is put in from the front to complete the lining ring.
So, the packers is basically
Each
fixing that
individual
one.
tunnel ring is
So,
built in a slightly conical
using this
form.
horizontal
This means that
drilling
curves
system,
can be built along the tunnel route by changing
the advance rate
direction
is
of the
very very
cone.
fast, where in conventional
hydraulic
method
cylinders
of
are extended
excavation
again to
you can
secure the
achieve around
segment
30
into
to 40
position.
meter per
During
month
all this
progress.
work,
You
the
can
people and
achieve 100
machines
meter
are protected by the
progress per
shield
month
skin from the
in case of
saturated
using
ground
this
where
large
water is
dia
under pressure.
tunnel
All
boring
the
machine.
readings are displayed on
However,
monitors in the
the
central
problem
control
associated
cabin
with
and
this
fed back
large
to the
dia
machine
tunnel boring
operator.
machine is that first the
Once
capital
each
requirement
section of
is
ring
very
building is
high.
completed,
So, a
the
TBM may
next
cost you
tunneling
around
phase can
50
start.
crore, 100 crore, something like that. So, the
The mixed
capital cost
shield
requirement is
TBMs
very
dig
high.
in a different way
And the
to
next
earth
is
pressure
that
balanced
the
TBM and will be
TBM
used for
installation
tunneling in waterlogged
time in the
conditions such as
underground
below the
is very
Thames.
high. So, first a pilot
Mixed
tunnel
shield
has to be
TBMs
created,
use
which may
bentonite,
be
which is a
of
slurry of clay
70
and
meter,
water
80
to
meter
support the
long for
excavation face
installing the
and act
TBM
as a
inside
suspension
that.
medium for
Then only
excavated
TBM start
material.
working. So, TBM can be
The excavation
adopted
chamber
only
is
for
behind
those
the
cases
cutting wheel and
where a
separated by
long tunnel
submerged
has to
wall
be
from the working chamber.
constructed. So, in this
The
case you can
excavation
see
is
the
completely
transportation
filled with
system is a
bentonite
slurry
and the
transportation
working
system
chamber
where
is
material is
approximately
cut
two-thirds
material is
filled.
being pumped out
The
not
two chambers
through the
are connected in the
screw
form of
conveyor system.
communicating
So,
pipes
basically
via
there are
an
n number of
opening in the
varieties. I
submerged
request
wall.
you can
A
see
filter cake
this
is
large
created
dia
ahead of the
horizontal
cutting
drilling,
wheel
n
by
number of
pressurizing the
animated videos
bentonite
are
in the
available in
working chamber
YouTube. You
with
can
compressed
observe them,
air.
then
The
it
bentonite
will be very
penetrates the
easy for
ground
you to
form a
understand
membrane which
those
holds back
things.
water. Changes in the soil can be handled by adjusting the pressurization. Through the suction line to the separation plane at the surface. Here the soil is separated out and removed from the bentonite suspension through a centrifuge, and the clean suspension is transferred back into the slurry circuit. As tunnelling advances, the flexible extension lines are installed to extend the lines after each thrust phase.
So, this is the
Crossrail's
pusher, how the
first
pusher
pair
is
of TBMs,
pushing the
Phillips
TBM
and
in the
Ava
front
will
direction,
construct Drive
so
X
that
travelling from Royal Oak to Farringdon. A second pair of TBMs, Elizabeth and Victoria, will construct
it
Drive
is
Y.
moving in the front
Limo
direction.
in Docklands
There is
and heading
another
to Central
little
London
bit
to
difficulties in TBM.
A further
The
two
TBM,
TBMs,
if
Mary and
TBM is
Sophia,
being
will
used
construct the
as the
tunnels to
construction of
Drive
the
H,
tunnel,
running
sharp
underneath
bend
the Thames
cannot
from
be
Hampstead to North
possible,
Woolwich, followed by
cannot
Drive
be
Z and
carried
Drive
out
G.
in the designing.
All the tunnels
It is
will be
very
completed by
difficult
the end of
to achieve it by
2014,
TBM, because
significant
TBM is
milestone in
having
the
a
programme to
longer
build the
length,
largest
it cannot
addition to the
sustain a
South
sudden
East Rail network
bend.
in 50
So,
years.
let us stop in this class at this position. We will continue the same topic in the next class also, with some other horizontal drilling and the flame cutting and water jet cutting. Thank you.